In this lesson, we're going to cover some special products in terms of factoring. Let's look when you multiplied opposite binomials like this, x minus 3 times x plus 3, you would get x squared minus 9. Well, now we're going to do this in reverse to factor. X squared minus 9 we call difference of squares, or difference of two squares. Why is that? Because the x squared and the 9 are both perfect square numbers, and there is a subtraction sign between them, thus the term difference of squares, difference of two squares. So anytime you see this format, you will know that you take the square root of the first term and place it in the front of the binomials, and take the square root of the last term and place it in the back of the binomials. So here we have an example. 9x squared minus 16 becomes 3x minus 4 times 3x plus 4, because the square root of 9x squared is 3x, and the square root of 16 is 4. So basically, once you recognize that the problem you have has two terms, and it is the difference of squares, you can easily factor it into two binomials. So I'm going to have you try a couple. I'm going to have you pause the video and work through both of these problems. Again, you've got your difference of squares. You simply follow the pattern to put it into the two binomials. You could always check yourself by multiplying them back together to see if you get your original problem. So pause the video and give those a try. Let's see how you did. So in the first one, I have 4x squared minus 49. 4 is a perfect square. 49 is a perfect square, as well as x squared. So I'm going to write down my two parentheses. The square root of 4x squared is simply 2x, so that goes in the front of the two parentheses. 49, that's a perfect square of 7 times 7, so we're going to put 7 and 7. And again, they have to have opposite signs, because when you multiplied them together, you ended up with a positive 14 and a negative 14x, and they would cancel each other out. So that is your answer to 4x squared minus 49 in factored form. Now let's try the second one. This one, I've got variables on both ends. X squared minus 4y squared. So the x squared, similar to what we've been doing before, is simply x times x. That's an easy pattern that we will do over and over again. Now the second term, 4 is a perfect square, but so is y squared. It's just like x squared, except it's got a y in it. So my 4 is going to become a 2, and my y squared is simply going to be y times y. And again, you need to have a plus minus, and no, it doesn't matter which one becomes minus, which ones become plus. So I could do it this way, minus first and plus in the second one, and I still get the same answer. There's another set of special products. One more type is called a perfect square trinomial, where the first and last term are perfect squares. The middle term is twice the product of the two square roots, which I will demonstrate here in a second. So the procedure is same as before. You take the square root of the first term and the last term, and you place respectively in the two binomials. So in this example, 4x squared plus 12x plus 9. I'm going to go ahead and again, I'm going to start with my two parentheses. 4x squared, the square root of that is 2x and 2x. 9, the square root of that is 3 times 3. The middle term is a plus, so they're both going to need to be a plus. And now you can see that the inside-outside terms, 3 times 2, those were the square roots of each side, that's 6x. And 3 times 2 the other way is another 6x. And that's where we get the initial 12x. So that's what we mean by double or twice the product of the two square roots. So the square root was 2 and 3. You multiply them together, you get 6. Double is 12. And that's how I knew it was a perfect trinomial. Next example, x squared minus 8x plus 16. So, obviously the first one is 1x times 1x. The square root of the last term, 16, is 4. And if you were to take the term number 4 and double it, you'd get 8. So again, I know it's a perfect square trinomial. Now, before, we know these have to be the same sign again because our last terms are always plus. But since our middle term is minus, these are both going to be x minus 4 times x minus 4. So these problems, when you do write them out, because they're identical, you could simply write them as x minus 4 squared as an example. Now let's have you try. 9x squared minus 30x plus 25. This meets our criteria. 9 is a perfect square. 25 is a perfect square. If I were to take the square root 3 and 5 and multiply them together and double it, I'd get 30. So you try putting this into its two binomial factors. Pause the video here and give it a shot. So let's take a look. Again, I'm going to take our two parentheses. The square root of 9x squared is 3x, and that goes in the front of each binomial. And the 25 is a perfect square of 5 times 5. My middle term was negative 30, so this is going to need to be both be a minus. Congratulations.